He is a passionate technologist, a thought leader, regular speaker, blogger, inventor, and a panelist in cyber and digital transformation forums. Please welcome Partha for AI for solving security challenges with microservices and serverless technology.
Thank you. Thank you. Good afternoon, everyone. So that was a lot of introduction about me. So one correction, right now I'm not with Guardian Life. Currently I'm working with Bank of Montreal. So that was my past role. So it's been like 3 weeks I'm working with Bank of Montreal. Here I am to talk about my experience and also like network. I already met a couple of people I met in other conferences and learn from your experience as well. Last 2 to 3 companies I worked with, they are mostly doing digital transformation and a cloud journey, right? Doing a cloud native or lift and shift, that has been always a discussion, and how security challenges are evolving in both the scenarios and how AI in particular are helping in most of the cyber tools when we talk about cloud native development with serverless architecture and microservices and a lot more. So it's amazing to see there is a cyber conference which is focused on AI because hardly we all are in either consumer or technical industry, and most of the time we're evaluating companies and products. Hardly we find any security tool which is coming that doesn't talk about AI and ML. I am not an AI and ML expert, by the way, but whatever tool we are using, there are challenges when we realize that defining something good or bad, or something bad coming under the hood of good, is not possible to define in a finite manner, right? And through all the configurations and all those stuffs we do. So we will talk about that and eventually we'll jump into it. So I will skip my introduction. I didn't realize that she already talked about everything, but most importantly, I'm a passionate in cybersecurity. I do participate in conferences, I do network and connect with LinkedIn, and I love learning from everyone and sharing the experience, which really helps during the product selection and implementation wherever companies I worked in the past. I like this quote from Forbes, right? So digital transformation is all about like doing less, be it serverless, timeless, and frictionless. I mean, delivering everything more with less. And every CIO we talk to or wherever we work, like everybody is taking up a digital journey. I mean, we have to deliver something faster than our competition. We have to give better user experience to our customers and clients to retain business. And in order to do that, we all realize that the traditional way of application development and deployment technologies are not helping us enough. So these technologies eventually came up over the course of last couple of years, and which are propelling the digital transformation and the adoption of digital transformation. Be it cloud native development, a lot of development in mobile technology space. Even the program management methodologies which are being used right now, no longer like a waterfall or any sequential fashion, right? We are going to agile, scaled agile, safe, and all those methodologies. Advent of 5G, so the combination, data analytics, API, so these are the things which are, when we talk about application development, all the developers talk about that, and these are the things which are propelling the digital transformation in each and every industry. Now, why is it important to us as a security professional? I mean, I have seen in my last 2 companies, be it JP Morgan, be it Guardian Life, and currently also I'm working here in Bank of Montreal, where digital transformation and cloud migration is a huge, huge initiative. So our traditional way of security has completely changed with the advent of these technologies like the microservices, and more importantly, the serverless, and how AI is coming to the picture. We will basically talk about that. These are the typical security controls we all use when we talk about application security. And it's no wonder, like every time we work, we follow some sort of a standard and guideline, right? I heard about in the panel discussion, CIS benchmark and NIST, right? So identify, detect, protect, respond, and recover. I mean, we can classify our security controls in these categories, and eventually, these are the tools which are used to protect our legacy or classic applications, which has been usually, most of the time, monolithic. And to be very honest, like there is no shame in accepting that lot of the digital transformation journeys where we are moving into cloud, these are mostly monolithic application. We lift and shift, and there is always a rush. We have to shut down our data center, close something, move into cloud, go into cloud. It will save a lot of money. And after a year, when we realize with that lift and shift model, when we move into cloud, we end up paying a lot of money, like the bill is not less. Then we realized that, okay, probably we should have taken a little bit more time, realized that we should have developed some cloud native applications. We should have done cloud native security as well. That would have been the maximum return on investment if we would have moved into cloud. But then the challenge comes, sticking into a single cloud or a multi-cloud option. The cloud vendors eventually lock us out with all the cloud native tools we go into. If we go into cloud native tools with Amazon, then we are stuck with Amazon. That particular thing will not work in Azure or GCP or any other provider. Or we can work with some third-party marketplace services. Again, like they don't equally balance. So that's a typical dilemma, right? A security guy has to face in all the cloud journey, right? So let's do a little bit of deeper dive into the differences we see between a monolithic application stack. Monolithic application worked really fine. Was very simple, like traditional web app, DB, message bus. Those are the tiers, and these are finite locations where they're installed. As a security guy, we inject security between a source or a destination, or in source or in a destination of any communication, right? So that the traffic passes through it, and we can see the traffic, and eventually we can make a decision. So in the traditional monolithic application development way, it was much more easier. I mean, we can implement at the perimeter those firewalls, web application firewall. We can do like WASP top 10 filtering. We can have endpoint control. We can have database activity monitoring, database firewall, all the controls we could have done. Now, what did not work in the digital transformation journey with monolithic application is that the business logic is a one single block of code. Every time we need to release a new functionality, we have to touch that particular block of code, and which could be like millions of lines of code. And every time we are doing it, we have to do a regression test because we don't know what else it is going to break, right? That's number one challenge. Number two challenge with a traditional way of doing monolithic application is that your development team, like now it's a global team everywhere, follow the sun model. Your developers are from different geography. They also have different skill set. Some are good in Scala or Angular or Java, right? But in a traditional monolithic way, if the code was written in a particular language, doesn't matter where the industry is moving, you have to keep developing in that because that is the only compatible way. So that becomes another blocker that you are hiring right people, and even for retention, like people want to do the latest and greatest technology, and if you are keeping them stuck with one particular way, I mean, people don't like it, and it's not even agile at all, right? So in order to overcome that, the software development industry came up with the microservices where they're breaking the business logic into chunk of smaller codes of smaller functions, which are language agnostic and independent. I mean, I can have a microservice written in language A, another can be written in language B. Eventually, when they talk to each other, they have a common set of understanding and protocol, they exchange information, and eventually the business application works. Because what matters is that, am I passing the right data at right parameter on the right call? And once we have that, it doesn't matter within that local microservice environment which language it is written or how it is talking to, right? So that helped solving that problem in most of the companies, right? Wherever we have seen is that you can fast track it. Like making a change in one microservice is not going to impact your entire regression test of your entire environment because it is completely isolated block. You can test it out, do a unit testing and release it, making it faster. You can write in different languages and different software development languages. That also does not impact. It actually fast tracks your development process. Now, what is the challenge? I mean, everything is good from a development perspective. If I'm a CIO, I love it, right? Okay, let's do cloud native. Let's pick up latest and greatest technology. Now, as a security professional, traditional security thinking is that consolidate everything, like a centralized point, so that you can have your inspection, detection, protection, everything in one single point, less headache for me. I can look into the traffic, I can take care of it, I can take any action I would like to take on the traffic. But with that microservices, now not only hundreds, thousands, if it spans across maybe millions, I don't even know, right? Whatever it is based on the business application we're running, it is getting so distributed. That means my security, right? In the panel discussion, there was a beautiful topic that data is the new parameter, right? Wherever the data moves, security moves with that. So wherever your microservice is moving, wherever your microservice is connecting, you have to take the same security control. You cannot compromise on security. If you have 10 or 20 or 30 checks for each one single monolithic application, when we are moving that in the microservices world, we have to take that thing, but we have to distribute across each and every microservice, which is just impossible for the security guys with scale, or even humanly with our brain. It's just not possible to do that, right? So in order to overcome that, like the technologies came up with, the services don't talk to each other, right? In this diagram, I tried to show the services use sort of a proxy sort of a concept. The services talk to a proxy, and proxies talk to each other. Proxy A is talking to proxy B, which means that the service, which is calling proxy, is actually talking to another service. The advantage of doing it is that we are decoupling the security, the network, latency, management, maintenance, and all those functions from the actual code, right? We are not relying on the developer to be security conscious and implement everything in the business logic or code. We are decoupling it, and we are putting on that standard service proxies which are available. And then it becomes my single point of inspection for that microservice, where the traditional concept still works. I can have my inspection and all the security controls implemented in proxy, right? Which really sounds good. The problem is that the scale. When those proxies are getting multiplied like hundreds and thousands, and you have an n-by-n communication between each, and like a matrix, right? Each proxy can talk to another proxy and all. That becomes the service mesh, right? In the actual microservices service mesh environment. Now, how you manage the security policy with those service mesh? And more importantly, right? Even if we define a policy that my proxy A can talk to proxy B and C because I have inspected those. I know that these are trusted. They have a mutual TLS. I trust that. There is an authorization, identity, and access management policies configured between that communication, which is all good. But what if something is compromised between one of those service proxies and service components, right? It can happen at any point of time. Are we able to segment it? Segmentation in a traditional environment, when we talk about a network, sounds really good. I mean, like there are a lot of segmentation vendors in the market. No offense to the segmentation vendor. It's not the problem of their technology. It's the problem of us using our applications and knowing our inventory of the application, which is good and which is bad, what should be allowed and what should be blocked. That complexity in the microservices, your environment gets so complicated, right, that it's humanly not possible to define that microsegmentation in a service mesh environment with thousands of service proxy connections happening. That's where the tools, and I'm not going to, first of all, name any vendor. We evaluated, and still we are working on some of the vendors you probably have encountered. Some are already listed in Gartner's, like advanced or niche. But what they're doing is they're utilizing AI in the service mesh communication, where they're inserting themselves in the path of the traffic. Eventually, the same security concept, basics, stays the same. I mean, in order to identify something good or bad, in order to implement a policy, whether it's allowed or denied, I have to see the traffic. And in order to see the traffic, I have to insert myself in the path of the traffic. So the same concept is being utilized here, even in the microservices communication, where they're inserting themselves in the path of the traffic in the service mesh control plane, where they have the visibility, right? This is on top of the mutual TLS and identity and access management policies which are defined, right? Or maybe the protection which is running, which is protecting the microservice, which could be running in a container, right? There could be a runtime application self-protection which is running, which is protecting the microservices. But in order to segment that microservices communication and reduce the risk further, right? AI is heavily being utilized to, under the hood, identify the traffic, even though there are two known good entities are communicating, whether the traffic pattern is good or bad. And based on that, defining a boundary, or these tools even integrate with compliance policies, whatever we integrate our template and profile, okay, if that policy is being breached, we have to create a boundary around that, which is humanly, without this technology, is not really, really possible. So there are some established vendors in the market. There are some upcoming vendors. There are startups in Israel, in US, and everywhere coming up. And our take is that this particular technology in AI is going to simplify it, which humanly we are currently not able to secure by manually defining our security policy and the construct around the microservices, right? So that's actually the challenge and the upcoming AI implementation to ease our deployment and our concern on the microservices space, which is very much used in digital transformation whenever we do and talk about the cloud native development. The next challenge is that, I mean, like a lot of times we have seen in the industry, right? I mean, like there was a time when McDonald's marketing was like, create the desire, right? I'm loving it, right? If 10 people say that I'm loving it, at some point of time, I really think about, I probably am loving it, right? I don't even know whether I love it or not. I see the same thing in serverless compute, right? All the organizations, even though we don't have a certain amount of maturity in our development and the security practice, but the technologies came up, and eventually it's driven by, if I go serverless, I'm going to save money. It is going to take care of my overhead. I don't have to allocate any compute, right, on the infrastructure where I'm deploying my functions, right, or components, which I'm running function as a service. So people are adopting. I mean, like there are organizations where, from the development community, CIO organization, we have to go serverless, right? I asked the question, why, right? What is the actual advantage? No, it's going to save us a lot of money and less headache, and we have to move it. So two different conversations. Either we tell that, okay, there are a lot of security challenges. Even Amazon, the native all identity and access management, CloudWatch, CloudTrail, tons of their security, guard duty, control hub, control tower, or even Azure, whatever we talk about, they will tell that, okay, we have adequate amount of monitoring and alerting technologies in place, but still, these are not secure. Because the core reason for this is that security has to be, you have to implement some security inspection tool, either between a source and destination, or at the source or at the destination. You have to see the traffic. If you cannot see the traffic and rely on something, somebody is telling, okay, that triggered something, how genuine it is, right? I mean, how are you going to trust that, yes, because I haven't seen the traffic, right? I got some API, it could be delayed, some alert or something, right? So serverless is nothing but a fancy term of the compute, CPU, memory, and everything is being allocated by the cloud provider, right? We don't have to allocate ourselves. Even when we spin up our compute with regular application, or even being microservices running on a Docker image or anything, like we spin up our EC2 instance or compute in AWS and equivalent thing in Azure or GCP, right, where we define which will be running. If the application is not running that duration of time, like then why I'm paying for that EC2 instance? If the application is running only like 15 minutes or 20 minutes, spinning up an EC2 for maybe a week or 2 weeks, I'm paying extra. Why should I pay that extra? That is usually the logic. And again, there is an overhead, right? There is no overhead for the developer to define the compute where it should be running and all those parameters. So we just tell, I need to run function X, and I give it to the cloud provider, and the cloud provider decides whether to run it on whatever compute, a shared compute, which is well segmented, like micro VM and everything is there, but they're going to decide, and it will be that ephemeral that after that compute is, after the program is run, 15 minutes or 20 minutes, whatever it is at max, it will destroy that compute, right? So this is a very high level of representation of the serverless, right, where the computes or the functions are shown in the cloud, which is calling a database, right, which is shown that it can be running anywhere in the cloud. And if it is running anywhere in the cloud, that becomes our traditional security challenge, that how do I see the traffic? Because I cannot install my security control because I just don't know where my function will be running. There is no dedicated or allotted IP or anything, right, which I know that where I will be able to install that thing. So that is one area where AI-based tools are coming up, right? So there are couple of techniques, and a very few vendor community have come up to solve this challenge. And I'm assuming the market will evolve, because every time I meet with my friends from AWS as well as Azure, the question is, are you going to help us in like 6 months or 12 months down the line? So what they do is that this depiction is exactly it. Like, it's a whack-a-mole sort of a think game, right? We just don't know where from it is going to pop up. Since I don't know where from it is going to pop up, where do I put my hammer, right? Where do I control? So in order to do that, there are technologies which came up, like the traditional controls are not going to work. It's basically embedding security, like the way securing wherever your data moves, depend on your data classification. Same thing, embedding a piece of control, part of the function, which will be running in the compute, right? And if I can do that, if I can self-create a boundary of my code, right, along with my function, then I'm somehow assured that it is going to protect my application at runtime. During build time, there will be traditional tools in application security, right? Static application scanning, dynamic application scanning, interactive application scanning. Static and dynamic is not going to help in serverless. Interactive is going to probably help a little bit better. But all those controls, like a layered defense in depth mechanism, will be there. There will be perimeter controls. I will have a slide where I will basically show the controls we implemented in some of the organizations where we worked. There will be perimeter controls, there will be endpoint controls, there will be traditional application security controls with static, dynamic, interactive scan, open source vulnerability, open source dependency, right? And all those assessments, and everything will be there. On top of it, there has to be a runtime protection. So that runtime protection will be runtime application self-protection technologies. There are a lot of vendors in Gartner Quadrant, like market is populated pretty much in that. The same RASP content, I call it like a RASP on diet in serverless compute. The same RASP concept where you embed a piece of code which will be part of your Docker image. Wherever it goes, it will be running. It will detect and protect and alert your application. The same thing will happen in serverless. The vendors, which are like, there are 2 or 3 vendors are prevalent in the market, excuse me, as of now, they embed a piece of code along with the application. That way, it gives you a peace of mind that wherever that application goes, I will see it will protect runtime boundary, any data interaction with my application. If it is something malicious and suspicious, right, it is not allowed, then it is going to protect. And it is also going to create alert and give me the visibility to my SOC, right, to my SIEM tool, whatever is needed. And those applications are also heavily dependent on AI. So in short, and this is actually a link, I think presentation will be shared, right? WASP actually came up with top 10 recommended controls for serverless compute specifically, right? Which is no longer a deviation. Like, these are a lot of, I call it like a fancy term, but the core concept of security still stays the same. It's a different way of, slightly different way of implementation, but same concepts as we do, like securing our traditional monolithic application stack or traditional security. So function as a service, or the serverless approach. So in this case, a piece of code like a RASP or a RASP on diet is embedded part of the function. Wherever the function goes, it runs. And at the same time, there are a lot of machine intelligence looking into the data pattern, behavior, and alerting and triggering. Does not matter which cloud provider or function as a service provider is providing it. It could be an on-prem Redshift, or it could be an Amazon Lambda instances, or whatever it is, right? So those technologies are gradually coming up. Very few vendors in the market right now, but I think big players, either there will be a merger and acquisition, or big players will come up with similar kind of a service where humanly we are not able to secure to that extent. We would love to protect our workloads, but with the help of AI tools and more development is including the companies I worked. And one is microsegmenting the microservices space, which is heavily dependent on AI, at the same time in the serverless space, where it's pretty much upcoming. Now, if you ask me which algorithm, which pattern they're doing it, I'm not an AI expert, but these are the areas where we are applying it, which manually we are not able to do it. So AI is getting more and more into that. The last one, and we will basically do Q&A. The last one is pretty much everything in one single view, right? So we have layered approach, defense in depth, right? The compute is different based on the compute. Either you have a PSI or you have a VSI, you have a container environment or you have a serverless environment, right? Serverless, you will have an FSP, functional self-protection at the runtime. Eventually, it will call a database, the database or micro database instances, which will be protected by a database firewall for vulnerability scan and everything. There will be database activity protection. And everything goes with a strong identity and access management, which, if possible, all the modern day techniques, right? OAuth or YDC Connect, right? A good federation. No longer passing on credentials through HTTP headers where it is clear text. Anybody can impersonate with IP spoofing. I mean, I'm not going to name, in my past job, there was a strong identity and access management control. We did a hackathon in 15 minutes. We were able to impersonate someone and get into that because all the information was passed on clear text with one of the big vendor tools through HTTP headers only, right? And they were not supporting all the latest and greatest technologies. So that is pretty much it. Like our perimeter, we have the WAF and then API gateway. API gateway, we have to incorporate doing additional inspection, like a layer 7 inspection and monitoring if possible. And then like the regular stuff, like RASP is a runtime protection. In serverless world, the serverless, the same thing like a RASP on diet, that's what I call. So this is kind of a stack that we have been following, right, in last 3 companies I'm working and building security controls around it. And before going into cloud with a cloud native deployment. So that's pretty much the presentation or the information I had. Open for any question if I can answer, or maybe we can, anything I can connect on LinkedIn and share and learn from your experience as well, what you guys see in your space.
You mentioned about the recommendation to integrate with the GitHub and part of the CI/CD pipeline since the beginning. What have been the most common and successful ways of embedding like the RASP technology in terms of like a high flow of application? So if you think about an enterprise which has around 1,000 apps,
yeah.
What is the model that you have seen that was successful in deploying that?
So 2 things. I mean, in my last job, what we did, number 1, RASP was running on the Docker level, container level, right? So whatever microservices was running, each container can have 5 or 10 microservices. But once I have a runtime protection, doing a basic data validation in that container, so that protects my microservices. Now the same concept when we go into the serverless world, then I don't have a container there, right? So I have to embed the same code, like a RASP Lite version, part of the function and deploy it. So that is purely a runtime protection. But in terms of a CI/CD pipeline integration, we have to be like a shift left methodology, right? Everything depending on the runtime is not a good defense. It can miss a lot of things. So we integrate, like these tools have an integration with the CI/CD pipeline. As it goes through all the scanning process and all, it tries to detect. And there are ways of detecting things and reporting back with an orchestration solution to a developer that we found 10 vulnerabilities, you fix it. At times, developer can fix it. At times, security is a beautiful world where we do risk acceptance. Like we do a lot of risk acceptance. Especially if you're in financial services, we're in the business of taking risk, right? A calculated risk. So you cannot have a risk-free that you fix everything and then you go in production. At some cases, they just cannot because technology is not there, timing and everything. So we do risk acceptance. So those cases which could not be fixed in the earlier CI/CD pipeline phase, and it is into the deployment phase, at least the runtime will add an additional defense in depth. But for traditional microservices which are running on a compute, right, instead of a serverless, at the Docker level, right? So at the container level.